Let's look at dimensional analysis problems involving measurements. Let's use as our first example figuring out how many nanometers there are in 736 centimeters. The first thing we're going to do is we're going to write our conversion factors. These are sometimes called per statements. So if we do that, we notice that centi is times 10 to the negative 2. Notice that the 1 goes next to the prefix, and that's always going to be the case whenever we write any of these per statements or conversion factors. So the 1 goes on the side with the prefix. So we have a statement for centimeters. We need to do the same thing for nanometers. We look at our chart. Nano is 10 to the negative 9th. And notice again, I wrote the 1 on the same side as the prefix. The last thing we're going to do is we're going to write out our calculations so that the units cancel to give us what we want, in this case to give us nanometers. We always start with the value that we were given, so we were given 736 centimeters. My first per statement, I used the top one, 1 times 10 to the negative 2 meter over 1 centimeter. Then I used the second one, 1 nanometer over 1 times 10 to the negative 9 meters, and when I put that in my calculator I get 7.36 times 10 to the 9th nanometers. The last thing I want to do is I want to make sure my units cancel out properly, because if my units don't cancel properly, that means I have one of these relationships upside down, most likely. So in this particular case, centimeters cancel with centimeters. I have a centimeter on the top and a centimeter on the bottom. And then I've got a meter on the top and a meter on the bottom, and that leaves me with only nanometers, which is what I wanted. Notice that in this problem, since both my given unit and the thing I was trying to find had prefixes, centi and nano, I needed 2 of these equalities, these per statements. Sometimes one of these won't have a prefix. For instance, in this problem, 2.29 times 10 to the negative 4th kilograms equals how many grams? You notice I have a prefix, a kilo or K, in front of the grams on this side, but nothing on this side. That means I only have to write the per statement for the kilo, and I don't have to worry about the other side. So I've written my conversion factor on my per statement. 1 kilogram equals 1 times 10 to the 3rd grams. Notice I always put the 1 on the side with the prefix. Now I write out my calculation. So I start with what I'm given, and I write 1 times 10 to the 3rd gram over 1 kilogram. And when I multiply this out, I get 0.229 grams. Now I do the last step, make sure my units cancel. So kilogram on the top cancels with kilogram on the bottom, and I'm left with grams. Sometimes these problems get a little bit trickier when we're dealing with measurements that are squared or cubed. For instance, if we want to find out how many millimeters squared there are in 349 kilometers squared, we're going to start off the problem the same way, writing our per statements. Looking at my chart, K is 10 to the 3rd. Notice again the 1 goes on the side with the prefix. This is good, but it's not what I want. You'll notice this is for kilometers, and I want kilometers squared, so I need to square both sides. When we square an exponent, it's the same thing as multiplying that exponent by 2, so our new per statement becomes 1 kilometer squared equals 1 times 10 to the 6th meters squared. Now we do the same thing for millimeters. Milli is 10 to the negative 3rd. Again, we don't want just millimeters, we want millimeters squared, so we square both sides, and that becomes 1 millimeter squared equals 1 times 10 to the negative 6 meters squared. So the 2 statements we're going to use, we're not going to use this one or this one. We're going to use the 2, this one and this one. Now we write our calculation to cancel out what we want to cancel out. So we write our given first, 349 kilometers squared. I've got 1 times 10 to the 6th meters squared for every 1 kilometer squared for my first statement. 1 millimeter squared for every 1 times 10 to the negative 6 meters squared for my second statement. And my calculator gives me 3.49 times 10 to the 14th millimeters squared. Make sure my units cancel out properly. Kilometers squared on the top, kilometers squared on the bottom, meters squared on the top cancels with meters squared on the bottom, leaving me with millimeters squared, which is what I want. Sometimes you'll be given a really tricky problem where you have a distance measurement cubed and you got to convert that to a volume. So for instance, if we want to find out how many kiloliters there are in 5.02 times 10 to the negative 2 hectometers cubed, they can look confusing at first because we have meters and we have liters. And meters is a distance measurement, while liters is a volume measurement. Now, the key is that there is one way we can relate one distance cubed to a volume, and that is that the definition of a milliliter is 1 centimeter cubed. So we're going to use this as our per statement to go from a distance measurement to a volume measurement. And the path that we're going to have to follow is first we convert hectometers cubed to centimeters cubed. And once we have centimeters cubed, we use this statement right here to convert to milliliters. And finally, we go from milliliters to kiloliters. So let's write out all of our per statements and see how we do this problem. So 1 hectometer equals 1 times 10 to the 2 meters, but we want hectometers cubed, so we cube both sides, and that becomes 1 hectometer cubed equals 1 times 10 to the 6th meters cubed. Do the same thing for centimeters, and we get 1 centimeter equals 1 times 10 to the negative 6 meters cubed. So we have all of the statements we need for part A. Part B, convert centimeters to milliliters. That's just using this right here. So I'm just going to not even write it over again. I'll just drag it down here. And finally, milliliters to kiloliters. So 1 milliliter equals 1 times 10 to the negative 3rd liter. And 1 kiloliter equals 1 times 10 to the 3rd liters. And now, finally, we have all of the statements we need. So 5 times 10 to the negative 2 hectometers times 1 times 10 to the 6th meters over 1 hectometer. From my first per statement, using my second one, I write 1 centimeter cubed over 1 times 10 to the negative 6 meters cubed. Then I go to my third one, and write 1 milliliter over 1 centimeter cubed. Then go to my fourth one and write 1 times 10 to the negative 3rd liters over 1 milliliter. And finally, I use my last one and write 1 kiloliter over 1 times 10 to the 3rd liters. Finally, I plug this all into my calculator and get 5.02 times 10 to the 4th kiloliters. Going back to make sure my units cancel, hectometers cancel with hectometers, meters on the top, meters on the bottom, centimeters on the top, centimeters on the bottom, milliliters on the top, milliliters on the bottom, liters on the top, and liters on the bottom. Leave me with only kiloliters. Finally, just very briefly, I want to point out to you that density can be used as a conversion factor. So if we have a liquid that has a density of 1.34 grams per milliliter, I can write a per statement that says 1.34 grams equals 1 milliliter. So if I wanted to know how many liters there are in 4.01 kilograms, well, since this is in kilograms and my per statement up here is in grams, I'm going to need one more statement where I go from kilograms to grams. So looking at my chart, kilo is 10 to the 3rd. I can write 1 kilogram equals 1 times 10 to the 3rd grams, making sure 1 goes with my prefix. Now I have my two per statements, the one that I get from density and the one that I get from my chart, and I can write, starting with my given amount, 4.01 kilograms, times from this per statement, 1 times 10 to the 3rd grams over 1 kilogram. Then using my density, 1 milliliter over 1.34 grams. Got this ratio, and if I stopped here and canceled out my units, I'd have kilograms cancel with kilograms, grams cancel with grams, and my answer would be in milliliters. And that would be good if I wanted an answer in milliliters. I need to go to liters, so I need one more statement, which I forgot to write at the beginning. That's why I'm mentioning it now. I should have written at the beginning also, since I had milliliters here and I wanted liters. 1 milliliter equals 1 times 10 to the negative third liter. Like I said, I apologize. I should have written this at the beginning. But when you go through a problem, if you have the wrong units, you can go back and look and see where you made your mistake. Using this last statement, I can now cancel out my milliliters and get to liters. And now when I plug this into my calculator, using the correct per statements with the 1 next to the milliliters, 1 next to milliliters, and so on, I get 2.99 liters.